Okay, so this one, number 15, wants me to find the first five terms in the explicit formula. So in order to do that, the explicit formula is a sub n equals d times n minus 1 plus a sub 1. I need to know d and I need to know a sub 1 in order to do that. So a sub 1 I don't know yet, so I need to find it. D they told me was negative 1.1. So to find a sub 1, I'm going to take the formula a sub n equals d times n minus 1 plus a sub 1. I'm going to plug in what I do know. I know d is negative 1.1, so I'm going to plug that in for d. And I know that a sub 38 is negative 53.2. So 38 is the n value. So that's going to go in for n. And negative 52, negative 53.2 is the a sub n value. So that's going to go in here. So I'm going to rewrite it as negative 53.2 equals d, which is negative 1.1, times n, which is 38, minus 1, plus a sub 1, because that's what I'm really looking for. And so if I do my math out, I get negative 53.2 equals negative 1.1 times 37 plus a sub 1, which gives me negative 53.2 equals negative 40.7 plus a sub 1. So I'm going to add 40.7 to both sides to get that a sub 1 is negative 12.5. So that means my explicit rule then must be a sub n equals d, which is negative 1.1, times n minus 1, plus a sub 1, which I just found was negative 12.5, so I can really write minus 12.5. And then the first five terms would be negative 12.5. Then I would take 1.1 away, so negative 13.6. Take 1.1 away again, negative 14.7, negative 15.8, and I'm going to run out of space, but it's negative 16.9. So those are the first five terms of the sequence. So this next one is asking me to find the recursive formula and then the three terms in the sequence after the last one that's given. So the three terms after the last one's given, we can start with that because the last one that was given was negative 1.4 and my common difference is 0.6. So to find my next term, I add 0.6. So that would be negative 0.8. Then add 0.6 again. That would be negative 0.2. And add 0.6 again to get positive 0.4. So those would be the next three terms. They also want us to write the recursive rule. So we need to find d and we need to find a sub 1. So d, which we know is 0.6, and a sub 1. So to find a sub 1, which we don't know, I'm actually going to use the explicit rule, even though it's asking for the recursive rule, because the recursive rule isn't very helpful in that case. So I'm going to take the explicit rule, a sub n equals d times n minus 1 plus a sub 1, and plug in d, plug in 21 for n, and negative 1.4 for a sub n. So I get negative 1.4 equals d, which is 0.6, times n, which is 21, minus 1, plus a sub 1. So negative 1.4 equals 0.6 times 20 plus a sub 1. 0.6 times 20 is 12. So that tells me that a sub 1 is negative 13.4. So my recursive rule would be a sub n equals a sub n minus 1 plus d, comma, a sub 1 equals negative 13.4. And then this last one asks me to write the recursive formula as well. So I need to find d, and I need to find a sub 1. So to find d, I'm going to make a table. So I'm going to make a table of n and a sub n values. So n is 18, when a sub n is 3,362. And then n is 38, when a sub n is 7,362. So I'm going to find d. d is the common difference. It's basically rate of change. So I want to see how much this goes up by, which is 4,000. And I want to see how much n goes up by, which is 20. So it went up 4,000 numbers in 20 sequence terms. So my common difference would be 200. And then I'm going to find a sub n, or a sub 1, the way I did in the previous examples, by plugging into the explicit formula. So I'm going to do a sub n equals d times n minus 1 plus a sub 1. And so d I just found was 200. N, I'm going to pick this first point in the table. So n is 18. And a sub n is 3,362. So if I solve that all out, I get that a sub 1 is negative 38. So my explicit rule, or my recursive rule rather, is going to be a sub n equals a sub n minus 1 plus d, which is 200, comma, a sub 1 we just found is negative 38.